Joe Van Dyke. I'm with Azima DLI. DLI Engineering began in the late 60s as an engineering consulting firm and has maintained a close proximity to the Puget Sound Naval Shipyard, and at the time qualified for a small business set-aside contract to do vibration measurements on the machinery on aircraft carriers. They asked us to develop a diagnostic system so that the vast amounts of data that were gathered on these machinery, vibration data, could be quickly processed. So you could take a computer on board, measure the data, get some diagnostics, and leave that with the ship. You know, we've kept up with the times. We have a very mature line of software and services that we provide for diagnostics worldwide and through many industries, certainly not just Navy contracts. Right now that's roughly 15% of our revenue. The rest comes from oil and gas, pulp and paper, power, pharmaceuticals, automotive manufacturing, the whole gambit of industrial clientele. Our diagnostic technology has always compared incoming vibration data to a baseline. We've got hundreds and hundreds of rules that are designed to detect things like imbalance, misalignment, bearing wear, and this is all based on knowing what exceedances of baseline at which frequencies mean what as far as diagnostics go. So this is our approach, and it was developed to mimic the human analyst thought process. The severity of the problem of bearing wear is based on the aggregate sum of the exceedance over the baseline. So as the vibration varies up and down due to loading or flow conditions or even temperature changes, these vibration peaks that are categorized as bearing wear indicators also will change to determine you know, the go-ahead plan on a machine may require that you take several measurements, 2 to 3, to see exactly where it is most commonly at on the severity scale. With the Fluke effort, we refined that default baseline quite substantially into something that is fine-tuned for certain machinery types. The Fluke product does not analyze without a baseline. It does analyze with a baseline, but that baseline is synthesized internally by algorithms that are fine-tuned based on the answers to the questions that the user provides. With good setup data, it's highly accurate on bearing wear and imbalance and misalignment and looseness. So we look at many, many cases and look at that aggregate sum of exceedances over average and fine-tune our system based on attempts to match exactly what the human analyst would assess as the severity of the problem. And then we would normalize that by dividing it by some factor so that the quotient there, if it's 1, then you have moved into from a slight, which would be below 1, to a moderate, which is above 1. And then if it gets to 3, then that's considered a serious. Gets to a 6, that's considered extreme. So we have these thresholds for that quotient. Most of these acceptance criteria are based on machinery type and normal vibration from those types of machines. So we have utilized our vast library of baselines that we have for machines to establish our own acceptance criteria. We don't benchmark against any acceptance criteria that are widely used in industry. Our best and most accepted studies were done on mature sets of machinery baselines, and we came up with a 98% agreement with the human analyst. The diagnostics that you obtain using the Fluke 810 are dependent heavily on the input data that's provided by the user. You can have no call when you really have a problematic machine, or you can have what's known as a false positive, where it says that you have a problem and you really don't. And this is because of the pattern recognition, which is the categorization of the peaks in the spectra, is thrown off. So it's very critical in most cases that you do enter the data that's required for the analysis. We're very happy with the end result here, and we think that it's a very good product that has a home amongst industrial users that are looking for some way that they can apply these standard known techniques to diagnosing problems with their machinery.